Hi there, this is Ms. Page. In this lesson, which is part of our Unit 2 on rational expressions, we are going to learn how to multiply and divide rational expressions. The nice thing is that the basic procedure is the same as we use to multiply and divide regular number fractions. So I just wanted to go over here prior knowledge of how we divide fractions, which have an extra step over multiplication. So remember that if we're going to divide two fractions, that we actually rewrite the problem first. Keep in mind, you cannot do any cross-canceling within a division problem. So our 8 and 10 cannot be reduced because of the division sign. If we had 8 tenths divided by something, then you could reduce the 8 and the 10, but not when they aren't part of the same fraction. What we do first, remember, is that we rewrite this part of the problem. And so the 9 tenths will remain the same. Our division becomes multiplication, and our 8/5 becomes 5/8. And we call that multiplying by the reciprocal. Then, once we're in multiplication form, with numbers, you kind of have two options. You can multiply straight across and then reduce, or you can reduce first through, say, cross-canceling at this point, because now we have multiplication and we have factors in this structure, and then multiply straight across. With rational expressions, we're definitely going to want to do our reducing first. Saves us time, saves us writing, all that kind of stuff. So we can reduce the 5 and the 10, shown here. They're reduced to a 1 and a 2, and then multiplying straight across gives us the final answer of 9/16. So this is describing, we're going to look at some multiplication problems first. So when we multiply two or more rational expressions, we're going to want to do all of our reducing within a single fraction or ratio, and also cross-canceling in this case because we're doing multiplication. In order to do that, we need to know common factors. So we're going to want to factor all of our numerators and denominators completely, including GCFs and all that kind of good stuff. Then whatever common factors we have, we'll reduce them as much as possible. Many of them will reduce to 1, but no, not all of them, especially with GCFs. And then whatever factors remain, we will multiply straight across. Notice it says removing all parentheses, which means that our numerator and denominator should both be in standard form, which is descending order of the powers of the variable. All right, so here's our first problem. So what I would do first, looking at this problem, is factor all numerators and denominators completely. Remember, factoring of trinomials and binomials can take more than one step, because if there's a GCF, you want to do that first, and then take whatever trinomial remains and look at factoring it into binomial factors. A monomial like 3x squared, you can leave alone. If you want to, you can rewrite it like as 3 times x squared, because I do want to make it clear that the 3 and the x squared are separate factors in that. So you can reduce the 3, you can reduce the x squared, or you can reduce both. With our denominator here, what I'm noticing, and I'm going to do a little bit of work up here, is there's a GCF of 3. And that gives me 3 times x squared minus 2x minus 8. So here now, I'm going to factor that trinomial into binomials, and I get x minus 4 and x plus 2. All right, so now I'm going to go on to this numerator. And this numerator I see has a GCF of 2. And that gives me this trinomial. So now I'm going to factor that trinomial, so I have my GCF of 2, and then the trinomial factors into x minus 5 and x plus 2. Then looking at this second denominator, I am looking at a GCF of x, and that's going to give me x squared minus 2x minus 15, and then factoring that, I'm going to get x minus 5 and x plus 3. All right, so once I have all of that factored, I am looking at, I can reduce my common factors, but I will say, notice that part of our instructions are to state excluded values, which we talked about in the first lesson when we reduced. And so you might want to do that now, and then do your reducing and write your simplest form of your answer. So that's what I'm going to do before I start crossing things out, because if I start crossing things out, it makes it harder to see what they were. And so your excluded values, remember these are values that our x variable cannot be equal to, all come from factors in the denominator, and where those factors, what value of x would make those factors equal to 0. So 3, which is a number, can't be 0, so I ignore that one. X minus 4 would be equal to 0 if x was 4, so x can't be 4. X plus 2 would be equal to 0 if x was negative 2, so x can't be negative 2. X would be equal to 0 if x was 0, so x can't be 0. X minus 5 would be equal to 0 if x was 5, so x can't be 5. And x plus 3 would be equal to 0 if x was equal to negative 3, so x can't be negative 3. I'm going to rewrite this because it honestly would be best if I have my numbers from least to greatest. That's a requirement for many problems when we list numbers. So this would be negative 3, negative 2, 0, 4, and 5. So these are my excluded values. And as long as you have that not equals there, it is very clear that those are the values that x cannot be. Then going back to my factored form of my problem, I'm going to now look at reducing. And you can start wherever, but you might want to go just focus on your numerator or your denominator and the individual factors in your numerator or denominator and see what you can reduce. For example, 3. I'm going to use my numerator here. So 3 is the first factor, and I look for a factor in my denominator that I can reduce with that. Notice I have a 3, so those 3's are going to reduce to 1. X squared. I'm looking for a monomial factor that I can reduce with x squared, and I can reduce the x squared with the x. They don't reduce to 1, but they do reduce to x. And I also like to circle my factors remaining that are not 1s. Makes it easier for me to find them for the next step. Then I hit a 2, and I don't have any parts of my GCFs that involve a factor of 2 anymore, so 2 is going to stay. Then I hit x minus 5, which I can reduce in the same ratio with this x minus 5. And then I have my x plus 2, which I can reduce with the x plus 2 cross-canceling over there, and they reduce to 1. So I have my x and my 2. Here I have to realize, okay, I have this x minus 4 and this x plus 3 left. So my simplest answer is going to be taking now and multiplying those remaining factors together. So x times 2 would become 2x over an x minus 4 times x plus 3 would become x squared minus x minus 12. And there's our simplest form of our final answer, both numerator and denominator in standard form. No common factors between them except for 1. All right, let's take a look at another problem. Okay, so basic procedure is the same. We're just kind of emphasizing that procedure at this point. So I'm going to look at factoring my numerators and denominators completely. So here I notice that my first numerator has a GCF of x, and that leaves me with x plus 8. And x plus 8 is a binomial that we would consider prime. It's not a special binomial that we can factor any further. So that's what I'm going to use for that numerator. My first denominator, I notice that I have a GCF of 3x. And if I factor that out, I get x plus 5. And x plus 5 is a prime binomial, so that one is done. Then I have my 6x plus 30, which has a GCF of 6. And I get another x plus 5, so that one's done. This trinomial, I have a GCF of 4, which gives me x squared plus 10x plus 16. And then, so I have the 4, and then I can factor that trinomial into 2 binomials of x plus 2 and x plus 8. So now again, don't forget, this is a common thing in these problems with the multiple parts. We get so into factoring, reducing, that we forget this part where we're supposed to state the excluded values of x. So now I'm looking at my factors in my denominator, because denominators can't be equal to 0, and those excluded values would be values that would make any factor in my denominator equal to 0. This time, 3x actually could be equal to 0 if x was 0. So that means x can't be 0. x plus 5 would be equal to 0 if x was equal to negative 5. So x can't be negative 5. 4 can't be 0 because there's no variable, so I skip over that one. X plus 2 could be equal to 0 if x was negative 2, so x can't be negative 2. And x plus 8 could be equal to 0 if x was negative 8, so we exclude that one also. So that means our excluded values from least to greatest would be negative 8, negative 5, negative 2, and 0. All right. So now going back to all the factored form I've got for my numerators and denominators. So again, I am going to go left to right, and I like focusing on my numerator, but I could use my denominator also. I'll use my denominator factors this time just to give you, a problem where I do that instead. So I'm going to start with my 3. Remember the 3 and the x, because they're both part of a GCF, they're individual factors that are reduced individually. So I'm looking for a factor I can reduce with 3, and I have this 6 here. So I have the 3, which gives me a 1, but the 6 becomes a 2. Now I'm moving to my x, and my x here I can reduce with the x here that's in this GCF. And those will in this case reduce to 1. And then I hit my x plus 5, which I can reduce with the x plus 5 over here. Then I hit the 4, and the 4 I can actually reduce with the 2 that's left over from the 6. So the 4 becomes a 2, and the 2 becomes a 1. This 2 is going to stick around because notice there's nothing else to reduce with it, but everything else now is 1s up here. Then I hit x plus 2, and x plus 2 I have nothing in a numerator to reduce with it, so I'm going to circle that, it's left over. And then my x plus 8 I can reduce with the other x plus 8 over here. So in my numerators, notice all I've got are a bunch of 1s. So remember that means our numerator is equal to 1. You can't get rid of a numerator of 1. So that makes our numerator 1, and then our denominator, we have the 2 times the x plus 2, and multiplying those together gives us 2x plus 4 for our standard form. And there's our final answer, our simplified product. All right, here's a practice problem. Please pause your video and give this one a try. Come back when you're ready to check. Let's take a look at the answer now. So hopefully this is what you came up with for excluded values and your simplified answer. If not, take a look at the work shown here. See that most common places to make mistakes are factoring incorrectly, and secondly, to lose factors that are still there. So the factors that are remaining are all in red. And so you got to be super careful that you don't lose little factors especially, but also binomial factors. All right, we are now going to move on to division. And the main difference here is our first step, that we first have to rewrite the problem using our procedure of multiplication by the reciprocal. After that, we'll have a multiplication problem, and we will do exactly the same things. There is another difference for excluded values, which I will explain fully in our first example here. So let's take a look at this problem. All right, so here I have a division problem, and I'm going to rewrite it as multiplication. Whether you do that and then do all your factoring, you do your factoring and then rewrite it, or you kind of try to do them both at once, doesn't really matter as long as you keep track of everything. I'll kind of break it down just for clarity in the example here. So I am going to first rewrite this as a multiplication problem. So remember, our first ratio remains the same. Division becomes multiplication, and then I flip my second ratio here. So my numerator is now the 2x squared minus 20x, and the denominator is the trinomial. All right, so now I'm going to do all my factoring. So in this first numerator, I have a GCF of 6x, and that would then be times x plus 2. Always good to check with multiplication to make sure that these two multiply together to get what you started with. Catch your mistakes that way. The first denominator has a GCF of 3. So even though I don't go through it thoroughly, I am in my head quickly multiplying to make sure everything seems to be working right. Multiplication. In the second numerator, I have a GCF of 2x, and that would be times x minus 10. And then I have a trinomial with a GCF of 1, so I'm going to look at binomials here. Looks like I have a 2x and an x, and I'm going to want a 2 and a 1, a plus and a minus. All right, let's talk about those excluded values. All right, division problems are a little bit more involved, and I'm going to explain why. So we know that denominators cannot be 0. So that means that excluded values would involve x values that make our denominator factors equal to 0. However, there's another situation here with division problems because we had to rewrite as multiplication. So when we're doing our excluded values, we are focusing on denominator factors, but because the original denominator was different and became this numerator, we also have to focus on these factors. That's what you have to remember for division and excluded values. So the 3 we can ignore because 3 can't be 0. X minus 10 would be 0 if x was 10, so x can't be 10. 2x minus 1, that's a little two-stepper, just be careful with the basic math here. Adding 1 is, remember, your first step, and then division, and so x can't be 1/2. Then we have x plus 2. That can't be 0, so that would be a -2 that x can't be. And then we have to go here. So 2x can't be 0 either, which means x can't be 0. And then we have another x minus 10. We've technically already done that one. You don't have to write 10 twice. Once is enough. So our excluded values from least to greatest would be -2, 0, 1/2, and the 10. All right, so now I am going to go back and I'm just gonna rewrite this part so I don't have all my circles in there. So we have 2x times x minus 10. So now I'm gonna reduce all common factors. So I'm gonna use my numerator again. So I'm looking at my 6, which is part of a GCF. So I'm looking for a factor in a GCF in my denominator I can reduce that with. And I have this 3. So the 3 becomes 1, the 6 becomes 2, and that's going to stay. This x, be careful, this x can only reduce with the power of x in the denominator as a GCF. So we don't have any x's in our denominator as GCFs, which means x is going to stay. The x plus 2 we can reduce with this factor of x plus 2 in the denominator. The 2 and the x both stay because, again, there's nothing in the denominator in a GCF to reduce them with. And then the x minus 10s will reduce to 1. So I've got 2x and 2 and x left in my numerator, and I've got 2x minus 1 left in my denominator. So as my final answer then, 2 times 2 is 4, and x times x is x squared, so I get 4x squared. And then I basically have 2x minus 1 times these 1's, so that is 2x minus 1. And there's our final answer to this division problem. All right, let's look at this one. So again, emphasizing our division problems. So again, first thing I'm going to do is rewrite as multiplication using my procedure multiply by reciprocal. So the first ratio always remains as is. Division becomes multiplication, and the second ratio flips. So x squared plus 2x is our numerator, and this trinomial is our denominator. Then I'm going to factor everything completely. The numerator here is x plus 7 times x plus 7. X squared is a monomial, so I'm going to leave it as is. X squared plus 2x is a GCF of x. And this trinomial denominator factors into x plus 7 times x plus 2. All right. So now I'm going to do my excluded values before I start crossing stuff out. So remember, this started as a division problem, which means my excluded values will come from the factors in the denominator, x squared, x plus 7, x plus 2, and factors in the second numerator that used to be a denominator, so the x and the x plus 2. So x cannot be. All right, if x squared cannot be 0. Think about it as like taking the square root of both sides. So x cannot be 0 because the square root of 0 is 0. X plus 7 can't be 0, which means x can't be negative 7. X plus 2 can't be 0, so x can't be negative 2. Then we hit x, so again, x can't be 0. We've already got 0 though, don't need to write it again, and we have another x plus 2, so that's going to give us another negative 2, which we don't have to write again. Least to greatest, that is going to be x can't be negative 7, negative 2, or 0, like so. So now I'm going to go back and I am going to look at reducing my common factors. So using my numerator. Now, in case it's not clear, when you reduce common factors, it's always a 1-to-1. So you can reduce one factor with one factor, and then they're gone. You can't do anything else with them. So this first x plus 7, I can reduce with this x plus 7. When I get to the next x plus 7, I don't have any other x plus 7, so this x plus 7 I'm stuck with. Then I have an x here, and I have an x squared over here, both monomial or GCF type factors. And so those reduce, this x becomes 1, and this x squared becomes x. And then I have x plus 2 over x plus 2, both of which would reduce themselves to a ratio of 1. So in my numerator, what I'm left with is x plus 7 times 1, giving me x plus 7. And in my denominator, x times 1, which gives me a denominator of x. And there's my final answer. All right. Pause your video here. Give this one a try. Don't forget to do excluded values. Let's take a look at the result now. All right, so down here, hopefully you came up with 4x plus 12 over x squared and those excluded values. If not, take a look at the work and try your best to find your error spots. All right, moving on. So what we're going to look at now will be still multiplication and division, but it will be using or involving monomials for our numerator and denominator, which means that we'll need some properties of our exponents, which apply. All right, let's take a look at this problem. Notice that the instructions now say to assume all denominators are not equal to 0. So that means that we don't have to worry about excluded values. We're assuming denominators will never be 0, so we don't have to exclude anything. All right. But we do have to find the product here. And notice that our numerators and denominators are all factors. We have some powers of x, some powers of y, some coefficients. We have some negative exponents, some positive exponents, negative and positive coefficients, all that kind of stuff. So what I would really recommend that you do first is on your powers with negative exponents is use the negative exponent property to change them to positive. And remember, we do that by moving the power out of wherever it is to the other location. So numerator powers would move to denominators, denominators to numerators. So coefficients are not affected. So I'm still going to have negative 3 and negative 2 times. I'm still going to have my 4 and my 9. They all stay exactly where they are. This power of x will now move to the denominator, and I'll have positive 5. This power of y moves to the denominator, and now I have positive 3. This power of x, which is already a positive 2, would stay in that denominator, and this power of y would move to the numerator, and I'd now have a positive 4. Over here, this power of x would move to the denominator, and now 6 is positive. The y, which is a positive 1 exponent, would stay. The x, which has a positive 1 exponent, would stay in that denominator, and this power of y would move up, and it would now have a positive 2 exponent. Fewer mistakes are made once all of your numbers for exponents are all positives. What I would recommend that you do now is reduce your coefficients. All right, some people like to multiply the coefficients and then reduce. You can do that, or you can do reducing cross-canceling as well, which is what I'm going to do here. So I have a negative divided by a negative, which is a positive. So I'm just going to say, all right, I've got positive is my sign now. The 2 and the 4 will reduce, giving me a 1 and a 2. The 3 and the 9 will reduce, giving me a 1 and a 3. So my final coefficients, I'm going to have a 2 and a 3. So now I'm going to look at combining my x's and y's. And what I would first do is just focus on what's in my numerator separately from what's in my denominator and multiply the like powers together. So all of my powers of y I can combine together by adding all of those exponents. So 4 plus 1 is 5, 5 plus 2 is 7. So I have a y to the 7th power. In my denominator, I can combine all these powers of x by adding their exponents. So I've got 5 plus 2, which is 7. 7 plus another 7 over here would give me 14. So I have x to the 14th power. And then this y is the only y, so it's y to the 3rd power. Now, when you simplify these and find the products, your final answer can have only one numerical value in the numerator, one numerical value in the denominator, one power of x, one power of y, or one power of each variable. So I now have to combine my two powers of y, and this uses our quotient property, which says that we should subtract these exponents. So I'm going to do the 7 minus 3, and that's going to make this y go away. And so now I have 2 times y to the 4th power over 3 times x to the 14th power as my final answer. All right, let's move on. So another type of problem, this one, however, you might notice is division. So what we want to do is, again, just like for all of our division of fractions problems, rewrite it by multiplying by the reciprocal first. So that means our first ratio stays the same. Then division becomes multiplication, and I'm going to flip this one. When you flip that ratio, all of your exponents stay the same. You're not using your negative exponent rule here. You're using the procedure of multiply by the reciprocal. So the reciprocal of this has to have the same expressions, just moved between denominator and numerator, like so. All right, so now what I'm going to do is I'm going to rewrite it so that all of my exponents are positive. And again, my coefficients at this point are all going to stay the same. And so I still have a negative 3 here, a negative 2 there. I have a 9 here and a 4 here. And so this power of x moves to the denominator, and now 5 is positive. This power of y moves, and now 3 is positive. This power of x already has a positive exponent, so it stays in that denominator. This power of y moves up, so the 4 becomes positive. Over here, x stays in this second numerator because x is to the positive power of 1. This power of y would move down, so the 2 is positive. This power of x moves up, so 6 is positive. This power of y stays because the 1 is positive. All right, so now what I'm looking at is, again, I might want to simplify my coefficients here, okay, as my next step. Notice that because of where the numbers are, that 2 has no common factors with 3 or 9, and neither does 4, so there's no reducing that's going to go on in our common factors, or rather in our coefficients rather, but we do have negative divided by negative, which becomes positive. So our final sign will be a positive. So this becomes 3 times 9, which is 27, and 2 times 4, which is 8. Those are our new coefficients. So now I'm going to just focus on my numerator and combine these powers of x by adding those exponents. So that's x to the 7th, and I have that y to the 4th over there. Here I'm going to combine these powers of x. So 5 plus 2 gives me x to the 7th, and combine the powers of y by adding those exponents. So 3 plus 2 plus 1 would give me y to the 6th power. Now I'm going to remember my final answer. I can have only one power of x, one power of y. This time my powers of x, you'll notice, match. So you can look at this a couple of different ways. Anything divided by itself reduces to 1. Also, quotient property, 7 minus 7 gives us x to the 0 power, and we have an exponent property that says anything to the 0 powers equal to 1. So either way, those reduce to 1. And then we combine our powers of y. I would do my subtraction by starting with my 6, because your final answer, ladies and gentlemen, your exponents need to be positive. That's also part of the expectation. No negative exponents in a final answer. So I would do the 6 minus 4. So that's going to mean this is going to go away, and the only thing left is 27 times 1, so that's a 27, and here I have my 8, and then this becomes y squared. And there is my final simplified answer. All right, here's a practice problem for you to try. Please pause. All right, let's take a look at the result. Okay, so hopefully you came up with this as your final answer. And if not, take a look at the work that's shown, compare it to yours, and try your best to figure out where you made any errors. That finishes up this particular lesson. I hope you have a wonderful day.